At 3:39 in the morning on January 21st, 1968, a United States Air Force B-52 Stratofortress carrying 4 hydrogen bombs crossed the coastline of Greenland at 30,000 feet and began to burn from the inside. The fire had started 11 minutes earlier, somewhere in the crew compartment. A seat cushion had fallen against a heating duct. The crew had detected the smoke at 3:28 a.m., declared an emergency, and begun the checklist for an emergency landing at Thule Air Base, 17 miles away. Thule was the most important American military installation in the Arctic, a base carved out of the Greenlandic ice, positioned to give American bombers the shortest possible flight path over the North Pole toward the Soviet Union. It had a runway long enough for a B-52. The crew needed 7 minutes to get there. They did not get 7 minutes. The fire spread faster than the crew could control it. At 3:39 a.m., the aircraft became uncontrollable. The co-pilot, Captain Leonard Svitenko, ordered the crew to bail out. 6 men ejected into the Arctic night at altitude over Baffin Bay. The pilot, Major Lawrence Messenger, stayed at the controls long enough to ensure his crew had cleared the aircraft. He ejected last. One crew member, Sergeant Loring Russell, was unable to eject in time. He died in the crash. The B-52 flew on without a crew for approximately 4 miles before it struck the sea ice of North Star Bay at approximately 220 miles per hour. The impact ruptured the fuel tanks. Roughly 50,000 pounds of jet fuel ignited instantly. The explosion and fire that followed covered more than half a square mile of ice. And somewhere in that burning wreckage, scattered across the frozen surface of a bay in northwestern Greenland, were 4 B-28 thermonuclear bombs. Each one carried a yield of approximately 1.1 megatons. Each one was more than 70 times more powerful than the bomb that destroyed Hiroshima. The men at Thule Air Base, who looked up and saw the glow on the horizon, did not know yet what they were looking at. They scrambled aircraft and vehicles. They sent helicopters into the dark. They began making calls up the chain of command that would, within the hour, reach Strategic Air Command headquarters in Omaha, the Pentagon, and the White House Situation Room. Those calls would set in motion the largest nuclear accident recovery operation ever conducted in Arctic territory. An operation that would involve 700 personnel, 4 months of round-the-clock work in conditions of extreme cold and darkness, and the removal of enough contaminated material to fill a warehouse. They would also set in motion a cover-up that would last nearly 3 decades and leave the workers who did the cleanup without the information they needed about what had been done to them. This is the story of what happened next. The frantic recovery operation, the cover-up that lasted 3 decades, the Danish government that was never told the truth, and the bomb that has never been fully recovered. The bomb that may still be out there, somewhere beneath the ice of North Star Bay, waiting. To understand what a B-52 carrying 4 hydrogen bombs was doing in the sky over Greenland at 3:28 in the morning, you have to understand the strategic logic of the Cold War in 1968 and a program called Chrome Dome. Chrome Dome was a Strategic Air Command airborne alert program that had been running since 1961. Under Chrome Dome, B-52s carrying nuclear weapons flew continuous airborne patrols along routes that brought them within striking distance of the Soviet Union. The logic was straightforward and terrifying in equal measure. If the Soviet Union launched a surprise first strike against American airfields, aircraft on the ground would be destroyed before they could respond. Aircraft already in the air, already armed, could survive that first strike and retaliate. The Airborne Alert was America's insurance policy against decapitation. At any given moment, during the height of Chrome Dome operations, there were 12 B-52s in the air, carrying live nuclear weapons over the Atlantic and Arctic Oceans, rotating through their patrol routes on missions that lasted up to 24 hours. The crews flew long, grinding patrols over open ocean and ice, maintaining radio contact with Strategic Air Command headquarters in Omaha, waiting for an order that everyone hoped would never come. The Thule Monitor mission was a specific variant of Chrome Dome designed to add another layer of assurance. A B-52 would circle Thule Air Base continuously, carrying nuclear weapons. If the base were destroyed by a Soviet strike, the airborne aircraft would know immediately. It would lose communication with the base and could respond. The mission was called Monitor because the aircraft was essentially watching the base from above, a nuclear-armed sentinel orbiting in the dark above the Arctic. The crew of the aircraft that crashed on January 21st had been flying for more than 11 hours. They had picked up the aircraft at Plattsburgh Air Force Base in New York and flown it north along the eastern seaboard, across the Davis Strait, and into the Arctic patrol route that circled Thule. They were near the end of their mission. Within an hour, they would have been cleared to land at Thule for crew rest before the return flight. The aircraft they were flying was a B-52G, Bureau serial number 58-0188, a mid-series variant of the Stratofortress that had been in service since 1959. The B-52G was the standard carrier for nuclear weapons on airborne alert missions in 1968, reliable, well understood by its crews, and capable of carrying a range of nuclear ordnance. The 4 B-28 bombs aboard 58-0188 were carried in the aircraft's bomb bay. They were fully armed. The safing systems, the mechanisms designed to prevent inadvertent detonation, were engaged, as they were required to be during transit, but the weapons were live in every relevant sense. They were ready to be employed on a valid order. They were ready to be a catastrophe on an invalid one. The seat cushion that started the fire was a foam-filled seat pad from a crew bunk in the lower deck of the aircraft. The bunk area was used for rest periods during long missions. Somehow, the exact mechanism was never definitively established. The cushion had come into contact with a heating duct running beneath the bunk. Foam is not fireproof. The heating duct was hot enough to ignite it. The fire began slowly, and then, as it found the aircraft's hydraulic fluid lines and wiring bundles, it grew quickly. By the time the crew smelled smoke and identified the source, the fire had been burning for several minutes. The navigator, Captain Curtis Criss, declared the emergency. The pilot turned toward Thule. The co-pilot began the emergency checklist. They were 17 miles out. At their approach speed, that was less than 5 minutes. They needed the fire to hold for 5 minutes. It did not. North Star Bay is a body of water on the northwestern coast of Greenland, roughly 4 miles wide and sheltered from the open sea ice of Baffin Bay by a headland to the north. In January, North Star Bay is frozen solid. The ice in 1968 was approximately 5 feet thick enough to land a small aircraft on in an emergency, thick enough to support heavy vehicles, but not thick enough to survive what was about to hit it. The B-52 struck the ice at a shallow angle and a speed that ensured there would be no recognizable structure left. The fuselage, wings, engines, and tail section were compressed into a debris field in the initial impact. The fuel ignited in the same instant. The fire that resulted was visible from Thule Air Base 17 miles away. Ground crews at the base saw the glow on the horizon and knew immediately that something catastrophic had occurred. The 4 B-28 bombs that had been aboard the aircraft did not explode in any nuclear sense. Let that be stated clearly, because it is one of the few unambiguously good facts in this story. A nuclear weapon cannot be detonated by fire or impact alone. The precise timing and symmetry of the conventional explosive charges surrounding the nuclear core must be achieved, and the aircraft crash and fire did not achieve it. But the B-28 did not need to detonate to cause an environmental catastrophe. Each bomb contained approximately 4 pounds of plutonium and several pounds of highly enriched uranium in its core. The conventional explosive charges surrounding those cores were triggered by the fire and impact, and they detonated, not in the symmetrical, precisely timed way required for nuclear detonation, but in the chaotic, violent way of bombs being thrown into a fire. Those conventional detonations shattered the weapons. They scattered radioactive material, plutonium, uranium, tritium, and beryllium, across the burning ice and into the smoke that rose from the crash site. The fire burned for approximately 20 minutes at extraordinary intensity. When it was done, the ice itself was contaminated. The snow was contaminated. The water that would eventually flow from the melting ice into North Star Bay was contaminated. The debris field stretched for roughly half a square mile. The 6 crew members who had ejected were scattered across a wide area of sea ice. They had parachuted into an Arctic night where the temperature was approximately minus 18 degrees Celsius. They were wearing flight suits and survival gear, but the survival gear had been designed for short-term use in emergencies, not for extended exposure in an Arctic winter. The base dispatched rescue helicopters immediately. All 6 were recovered. 3 had suffered injuries during ejection or landing. All survived. Sergeant Loring Russell, who had been unable to eject, was never found. The crash site was searched, but the intensity of the fire and the destruction it had, base was north of the Arctic Circle, and in 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 the Arctic base was determining which weapon each fragment belonged to, building toward the confirmation that all four weapons had been located in some form. The conditions under which the work was conducted would be difficult to overstate. January and February in northwestern Greenland involve polar night, meaning the sun does not rise above the horizon at all. Workers operated in darkness or in the twilight of headlights and portable lighting equipment. Temperatures routinely fell to minus 40 degrees Celsius or below when the wind was factored in. Equipment that functioned normally at temperate latitudes failed. Vehicles broke down. Instruments gave unreliable readings. The radiation monitoring equipment that was supposed to track contamination levels was affected by the cold in ways that produced inconsistent data. Workers wore so many layers of cold weather clothing that fine motor tasks became difficult, and the handling of small, contaminated fragments required a level of dexterity that was nearly impossible to achieve in Arctic mittens. The ice itself was a problem. As the weeks passed and the Arctic moved toward the slightly less brutal conditions of March and April, the contaminated ice at the crash site began to show signs of instability. The heat of the original fire had weakened the ice in the crash zone. Spring was coming. The recovery teams worked with the knowledge that the ice beneath them was finite, not in the existential sense, though working on 5 feet of ice over 30 meters of water in the dark at minus 40 degrees has a certain concentrating quality, but in the operational sense. Every day that passed without completing the recovery was a day closer to the ice breaking up and taking whatever remained with it to the bottom of the bay. By the time the sea ice began to break up in the spring of 1968, the American recovery operation had removed most of what it could find. Most, but not all. Because the fourth bomb had not been found. Not its core, not its secondary, not enough of its components to account for a weapon. Parts of it had been identified in the debris field. Fragments of casing, components that were recognizably from a B-28, but the weapon itself, in any meaningful sense, had not been recovered. The official position the American military took, and has maintained ever since, is that the fourth bomb was sufficiently recovered, that enough components were found to account for the weapon's radioactive materials, that no intact bomb core went into the sea. The official position is careful and precise in its language. It does not say the bomb was fully recovered. It says enough material was recovered to assess that no intact device entered the water. That is not the same thing. The Kingdom of Denmark has a complicated and often uncomfortable relationship with Greenland. Greenland is a Danish autonomous territory, constitutionally part of the Kingdom of Denmark, with its own government and its own history of colonization that remains a source of ongoing political tension. In 1968, Greenland was a Danish territory under considerably more direct Danish control than it exercises today. Thule Air Base existed on Danish territory under an agreement that the Danish government had negotiated with the United States in 1951 as part of Denmark's NATO membership. That agreement, known as the Defense Agreement, defined the terms under which the United States could operate Thule. It was a defense agreement, not a weapons storage agreement. Denmark had a policy, stated publicly, maintained firmly, and politically important to the Danish population, of not allowing nuclear weapons on Danish soil or in Danish waters in peacetime. This policy was the reason that the American nuclear-armed aircraft flying Chrome Dome missions from Thule were a problem that both governments preferred not to examine too closely. The aircraft were based at Plattsburgh and other American bases. They flew to Thule, circled, and returned. Technically, they did not land at Thule with weapons aboard. Technically, the weapons were never on Danish soil. The Danish government maintained this distinction carefully, and the American government did nothing to disturb it. When the crash occurred, the Danish government was informed that a B-52 had crashed at Thule. It was not informed initially that the aircraft had been carrying nuclear weapons. The Danish Prime Minister, Hilmar Baunsgaard, was told about the crash, but was not told about the weapons. The Danish Foreign Minister was told. The Danish Defense Minister was told. They were told in terms that made clear they were not to make public statements about the weapons, and that the information was being shared in strict confidence. The Danish public was told a B-52 had crashed at Thule and that recovery operations were underway. The nature of those recovery operations, the 700 personnel, the 237,000 cubic feet of contaminated material, the search for a missing nuclear weapon, was not disclosed. The cover-up was not a single decision made by a single person. It was the product of a bureaucratic logic that was deeply embedded in Cold War nuclear governance. The fewer people who knew about nuclear weapons incidents, the less public pressure there would be to change the policies that made those incidents possible. Chrome Dome was already under review after the Thule crash. It would be terminated within months. But the review and termination were conducted quietly, as internal military policy decisions. They were not the result of public accountability. The Danish workers who had been hired to assist with the recovery operation were another problem. Several hundred Danish civilian workers from local communities near Thule had worked on the cleanup. They had been exposed to radiation. They had been told, inconsistently, incompletely, and sometimes inaccurately, about the nature of the hazard. When they returned to their communities and began, years later, to develop health problems, they had no reliable documentation of what they had been exposed to, or for how long. The Danish government's knowledge of what had actually happened at Thule was limited by what the United States chose to tell it. What the United States chose to tell it was limited by what the United States wanted to acknowledge. And what the United States wanted to acknowledge was shaped by the legal, political, and strategic implications of acknowledging that a nuclear-armed aircraft had been conducting operations from NATO's most northerly base in violation of Danish anti-nuclear policy. For nearly 3 decades, the gap between what had happened and what was publicly acknowledged remained wide and largely unexamined. That began to change in the 1990s. The mechanism of the cover-up deserves examination because it was not crude. It did not involve falsifying records or ordering witnesses to lie. It involved the careful management of what was disclosed, to whom, and in what terms. The Danish government was told there had been a crash. Senior Danish officials were told, in confidence, that nuclear weapons had been involved. The Danish public was not told. Danish workers who participated in the cleanup were given incomplete safety briefings. The official American account of the cleanup described it as successful and thorough, which was true in the sense that most of the contamination had been removed and most of the weapons had been accounted for. It omitted the parts that were not fully resolved. This kind of managed disclosure is not the same as lying, and the people who practiced it would not have described it as dishonesty. They would have described it as the appropriate handling of sensitive nuclear information in a way that balanced accountability with security. The problem with that framing is that it places the judgment about what the public and affected workers need to know entirely with the institutions that have the most to lose from full disclosure. It produces exactly the outcome that has characterized every Cold War nuclear incident: partial acknowledgement, delayed compensation, and a generation of affected people navigating bureaucratic resistance without the documentation they need. The 1990s were, for Cold War secrets, a decade of partial reckoning. The Soviet Union's collapse had opened archives and released former officials from their oaths of silence. In the United States, the Clinton administration's declassification review program was releasing thousands of previously secret documents. In Denmark, a team of researchers had begun investigating what had actually happened at Thule in January 1968, driven partly by the health claims of former Danish workers and partly by a growing journalistic interest in Cold War secrets that had been kept from the Danish public. The Danish Institute for Clinical Epidemiology produced a study in 1987 that found elevated rates of certain cancers among workers who had participated in the Thule cleanup. The study was contested, as such studies always are. Establishing causation between radiation, exposure, and cancer decades later is methodologically difficult, and the American and Danish governments both had reasons to contest the methodology. But the study existed. It had been published. It was being discussed. The workers who had been there were talking to journalists and researchers, and what they described did not match the official account of a contained, well-managed cleanup operation. In 1995, the Danish government commissioned a formal investigation into the Thule incident. The investigation, conducted by the Danish Institute for Clinical Epidemiology and later supplemented by historical research, produced a report that was published in 1997. The report documented the health claims of the Danish workers, the inconsistency of the radiation monitoring that had been conducted during the cleanup, and the gap between what Danish workers had been told about the hazards and what American officials had known at the time. It also documented for the first time in a public, Danish government document that the aircraft had been carrying nuclear weapons, that those weapons had been damaged and scattered across the crash site, and that the cleanup operation had been conducted under significant time pressure with inadequate protective measures for many of the workers involved. The American government, in response to inquiries from the Danish investigation, declassified a series of documents related to the Thule incident. Among those documents was a 1968 report from the Atomic Energy Commission that described the recovery operation in detail, including the recovery status of each of the 4 weapons. The report confirmed what had been suspected. The 4th weapon had not been fully recovered. The report's language was careful. It noted that residual radioactive material from the fourth weapon remained unaccounted for, and that the search of the crash site and the sea ice had not conclusively located all components of the weapon. The report did not say an intact bomb was on the bottom of North Star Bay. It said that not everything from the fourth bomb had been found. The distinction matters, but it matters less to the families of the Danish workers who developed cancers and to the researchers who have spent decades trying to get a straight answer than it might to the lawyers and officials who drafted that language. What the 1997 Danish report and the subsequent American declassifications confirmed was a pattern that will be familiar to anyone who has studied how governments manage nuclear incidents. The minimization of public information, the prioritization of strategic secrecy over accountability to affected populations, and the long delay between the incident and any meaningful public reckoning. 29 years had passed between the crash and the Danish government's first thorough public investigation. 29 years during which Danish workers who had been contaminated had been left without reliable information about what had happened to them and why some of them were sick. The American government's response to the Danish investigation was, by the standards of Cold War nuclear transparency, relatively forthcoming. Documents were released. Officials were made available for interviews. The AEC report was declassified. But the core question, where is the fourth bomb, or what remains of it, was never answered with the clarity the Danish investigators sought. North Star Bay is not a deep body of water. It averages approximately 30 meters in depth. In winter, it freezes solid. In summer, its ice melts, and its waters are open to navigation. Every winter since 1968, the ice has formed again. Every summer, it has melted. The contamination that was not removed from the surface in the spring of 1968 has, over the decades, been cycled through this process of freezing and thawing, dispersed by currents, redistributed by time. The question of the fourth bomb has two components. The first is whether an intact weapon, core, a sphere of weapons-grade plutonium surrounded by beryllium and conventional explosive, went into the water or was pulverized in the crash and fire. The official American position is the latter, that the conventional explosives detonated in the crash, that the fissile core was dispersed rather than intact, and that what went into the water was contaminated fragments rather than a recoverable weapon. The second component is whether those contaminated fragments represent an ongoing environmental hazard. Here, the scientific picture is murkier. Plutonium-239, the primary fissile material in a B-28 warhead, has a half-life of 24,000 years. It is not going away. It is not being rendered harmless by the passage of time. The plutonium that was deposited in North Star Bay in January 1968 will still be there in any meaningful sense when the sun expands to consume the inner solar system. The question is not whether it is there, but what state it is in, and whether it poses a hazard to the marine environment and to the people who fish and live in the region. Danish and Greenlandic researchers have conducted periodic surveys of sediment contamination in North Star Bay since the 1990s. The surveys have consistently found elevated plutonium levels in bay sediments compared to background levels. The contamination is measurable. It is above what would be present from global fallout alone. It is consistent with the 1968 crash being a source. The surveys have also consistently found that the contamination is largely contained within the sediment and does not appear to be entering the food chain at levels that would represent an immediate health threat to people consuming fish from the bay. That assessment is qualified, provisional, and dependent on the continued stability of the sediment. Climate change is not a stable background condition. The Arctic is warming faster than any other region on Earth. The permafrost that underlies much of Greenland is thawing. The sea ice, patterns that have characterized North Star Bay for centuries, are changing. The sediment disturbance patterns in a warming Arctic are not the same as in the stable Arctic of the 1970s and 1980s, when the initial contamination assessments were conducted. Whether the plutonium currently sitting in North Star Bay sediment will remain stably sequestered as the Arctic changes is a question that the existing monitoring program was not designed to answer. The Greenlandic government has repeatedly asked Denmark and the United States for more comprehensive monitoring and for greater transparency about what is actually in the bay. The monitoring has been periodic rather than continuous. The transparency has been partial rather than complete. The gap between what is being measured and what the people who live and fish near North Star Bay need to know remains. The scientific monitoring that has been conducted in North Star Bay since the 1990s uses sediment core sampling and water column analysis to track plutonium concentrations. The methodology is sound. The samples show a consistent pattern: elevated plutonium-239 and americium-241, a decay product of plutonium, in sediments at depths consistent with the 1968 crash site, tapering off as the sampling moves away from the crash area. The contamination is real, measurable, and clearly connected to the 1968 event. The question of whether it is hazardous at current levels is, as scientists will tell you with precision, and as affected communities will tell you with frustration, genuinely uncertain. What is certain is that the uncertainty is not being resolved with the urgency the situation might seem to warrant. The monitoring is episodic. Surveys conducted every several years rather than continuous monitoring. The funding for monitoring comes from Danish government budgets that are subject to political priorities. The Greenlandic government, which represents the people most directly affected, has limited independent scientific capacity and must rely on Danish and international researchers whose access to the site is itself contingent on Danish-American cooperation. The triangle of interests, Greenlandic community needs, Danish political responsibility, American strategic interest in not reopening questions about nuclear incidents, does not consistently produce the most thorough possible scientific assessment. There is also the question of what no longer exists. The United States ended the Chrome Dome program in 1968, following the Thule crash. The program had been under review before the crash. There had been other accidents, other close calls, other moments when the logic of flying nuclear weapons continuously over open ocean had been questioned. The Thule crash made the argument for termination unanswerable. Chrome Dome ended. The era of continuously airborne nuclear weapons, weapons flying over Allied territory on alert missions that those allies had not fully consented to, ended with it. But the ending of Chrome Dome did not end the larger question it raised, the question of what obligations nuclear-armed states have to the people in whose territory they operate nuclear weapons, the question of what information governments owe their own citizens and their allies when nuclear accidents occur, the question of whether the people most exposed to the consequences of nuclear policy, the workers who cleaned up the crash site, the Greenlandic communities who live near North Star Bay, have a right to full accountability. Those questions outlasted Chrome Dome by decades. They remain unanswered. Among the most important and least told parts of the Thule story are the people who did the cleanup and what happened to them afterward. The Danish workers who participated in Operation Crested Ice came from a variety of backgrounds. Some were civilian contractors employed by the Danish company that held maintenance and support contracts at Thule. Some were Danish military personnel. Some were workers recruited specifically for the cleanup. They were told they would be working at the crash site. They were given varying amounts of information about the nature of the hazard. Some received briefings that described the radioactive contamination in general terms. Others received little briefing at all. The protective equipment available in 1968 was the product of its era. Respirators were available, but not always worn, partly because in extreme cold, the moisture from breathing rapidly makes a standard respirator nearly unusable. Film badges for radiation monitoring were distributed inconsistently. Some workers received badges and were monitored. Others worked without monitoring equipment. The records of who worked where and for how long were incomplete from the beginning, a problem that would make it extremely difficult to reconstruct individual exposure estimates decades later. The American military workers who participated in the cleanup were in somewhat better shape, at least in terms of the subsequent record keeping. The U.S. Air Force maintained occupational health records for its personnel, and those records could be, and in some cases were, used to track health outcomes. The Danish civilian workers had no equivalent record system. When they developed health problems in the 1970s and 1980s and tried to establish a connection to their Thule service, they found themselves facing the standard bureaucratic response to workers seeking compensation for occupational illness, requests for documentation that had never been created, demands for evidence that had never been collected, and institutional resistance from organizations whose financial and reputational interests lay in minimizing the connection between the cleanup and the health problems. The Danish Cancer Society study of 1987 and the subsequent Danish government investigations produced some acknowledgement of the problem. The Danish government established a compensation fund for Thule workers who could demonstrate participation in the cleanup and who had developed conditions associated with radiation exposure. The fund paid some claims. It rejected others. The criteria for acceptance were contested. Workers who believed their cancers were connected to Thule found themselves arguing with bureaucrats about epidemiological methodology and causation standards in a context where the documentation they needed had never been properly maintained. One of the most painful aspects of the Thule workers' experience is the timeline. The Danish government's formal investigation did not produce its report until 1997, 29 years after the crash. The workers who had been young men in 1968 were in their 50s and 60s by the time any official acknowledgement of their exposure was made. Some of them had already died. The documentation of their exposures, which would have been possible to create in 1968, no longer existed. The connection between their service and their health, which might have been established with careful longitudinal monitoring, had never been studied in real time. This is a pattern that appears in almost every nuclear incident of the Cold War era. The populations most exposed to the consequences of nuclear operations, the downwinders in Nevada and Utah who lived beneath the fallout from American weapons tests, the Marshall Islanders who were displaced by Pacific tests, the workers at Hanford and Savannah River and Rocky Flats who processed nuclear materials, faced a consistent combination of inadequate monitoring during exposure, restricted information about the nature of the hazard, and delayed, partial, and contested acknowledgement of harm decades after the fact. The Thule workers are one chapter in a much longer story. The Thule Air Base crash of January 21, 1968, is classified in American military records as a broken arrow, the official designation for an accident involving nuclear weapons that does not create the risk of war, but does involve the accidental damage, loss, or destruction of a nuclear weapon. The United States has officially acknowledged 32 broken arrow incidents in its history. Unofficial estimates by researchers who have studied the declassified records suggest the true number may be considerably higher. Of those acknowledged incidents, Thule is among the most significant in terms of environmental impact and the least resolved in terms of accountability. The Palomares incident in Spain in 1966, where 4 hydrogen bombs fell from a B-52 and 2 of them contaminated Spanish farmland with plutonium, produced a decades-long diplomatic dispute and eventually a partial American cleanup contribution in 2015, nearly 50 years after the accident. The Thule incident has produced less. The contamination remains in North Star Bay. The monitoring is periodic. The compensation for Danish workers is contested. The 4th bomb is where it has always been, not fully accounted for, not fully recovered, not the subject of a cleanup plan commensurate with the scale of the problem. Thule Air Base still exists. It has been renamed Pituffik Space Base, and its mission has shifted from Cold War nuclear alert to missile defense and space surveillance. The runway that the crew of the crashed B-52 were 17 miles away from when their aircraft became uncontrollable is still there, still operational, still serving American military purposes on Danish territory under the terms of an agreement that is periodically renewed and periodically contested by Greenlandic politicians who argue that the terms under which their territory was committed to American military use were never properly negotiated with the Greenlandic people. North Star Bay still freezes in winter and thaws in summer. The fishermen who fish its waters, the hunters who cross its ice, the Greenlandic communities that depend on its marine resources continue to live alongside a contamination that their government has repeatedly requested more information about and repeatedly been given partial answers. The 6 crew members who survived the crash continued their military careers. Major Messenger received a commendation for remaining at the controls until his crew had ejected. The crew members' service records do not reflect the fact that they nearly caused the largest nuclear contamination incident in Arctic history. They did not nearly cause it in the sense of failure. They followed their emergency procedures correctly. They ejected when ordered to. The pilot stayed at the controls as long as he could. The near catastrophe was not the crew's fault. It was the product of a system that was flying nuclear weapons continuously over Arctic territory in a program that combined operational necessity, strategic logic, and an acceptance of risk to Allied territory and populations that those populations had not been fully informed about and had not fully consented to. Sergeant Loring Russell, the one crew member who did not survive, is commemorated on the Air Force Memorial at Thule. He was 22 years old. The seat cushion that started the fire has never been identified. It was presumably consumed in the crash. The chain of causation that connects a foam cushion in a bunk above a heating duct to 237,000 cubic feet of contaminated Arctic ice to a missing bomb component sitting under North Star Bay, to thousands of Danish workers whose health records were never properly kept. That chain is as clean and unsparing as any in Cold War history. The smallest possible cause, the largest possible consequence, and a 60-year gap between the event and anything resembling full accountability. The Cold War produced many such gaps. It produced them through the logic of secrecy, the idea that national security required that certain things not be publicly known, that the management of nuclear risks was too complex and too sensitive to be subject to normal democratic accountability. That logic was not entirely wrong. Nuclear weapons policy does require security. Some things cannot be publicly disclosed without operational cost. But the Thule case illustrates what happens when the logic of secrecy is extended past its legitimate boundary. When it begins to cover not just operational details, but the health of workers, the contamination of territory, and the basic information that affected populations need to make decisions about their own lives. The workers who cleaned the ice of North Star Bay in the winter of 1968 were not nuclear policy analysts. They were contractors and soldiers doing a job they had been assigned. They deserved to know what they were being asked to handle. They deserved to have their exposure documented. They deserved, decades later, to have that documentation available when they or their doctors needed it. The fact that they did not have those things is not a side effect of nuclear security. It is a choice that was made by institutions that prioritize their own protection over the well-being of the people who serve them. That choice, made in a freezing bay in northwestern Greenland in the winter of 1968, is still being paid for. If this story is new to you, hit the like button. These are the stories that get buried, not because they are unimportant, but because they are inconvenient. Subscribe and turn on notifications. We are here every week, pulling the inconvenient stories out of the archives and putting them where they belong, in front of people who deserve to know them. Drop a comment. Tell us where you are watching from. Tell us what you knew about Thule before today. And share this video with someone who thinks the Cold War was fought by generals and politicians. It was also fought by a 22-year-old sergeant on a night flight over Greenland who never came home.